Hello student, I'm your physics teacher Neelasi. Welcome you in our first lecture of physics in which we are going to discuss our first unit electrostatic. Our first unit electrostatic have different chapters. For example, in first chapter of electrostatic we study electrostatic force and electric field. Then in second chapter we study electrostatic potential, and then after we study electric capacitance and the device related to electrostatic. Okay, in next video we will discuss electric field and electric field lines. Okay, so let's start with the definition of electrostatic. So what is electrostatic? Electrostatic is the branch of physics in which we study the behavior, properties of charge when it is at rest. Electrostatic is made up of two words, that is electron plus stat or statics. So electrostatics means electron at rest. That's why it is called electrostatics. Okay, here's the definition also. The study of charge and its property and the study of charge and properties when the charge is at rest is called electrostatic. I hope this is clear to you. Okay, now come to next definition, electrodynamics. We are going to study only electrostatic in this chapter. We are not going to study electrodynamics. Electrodynamics is another branch of physics in which we study the behavior of electron, but not in static condition but in dynamic condition. Okay, dynamics. So electrodynamics is also made up of two words. Electron plus dynamic means electron at motion. So electrodynamics is a branch of physics in which we study the force or property of charge when the charge is in motion. I hope you are clear with these two terminologies, that is what is electrostatic and what is electrodynamics. Now let's have an overview that what are going to study under this video. So firstly we will discuss what is frictional electricity, then we will discuss properties of electric charge, thereafter we will study Coulomb's law. Okay, after that, since the Coulomb law is related to force, so we have to study force in its vector form also. So we will study Coulomb's law in vector form. Then we will define the unit of charge, and since the force is affected by the medium in which two charges are placed, so that's why we have to study the relative permittivity and dielectric constant of the medium. Okay, after that we will study different types of charge distribution, for example line charge distribution, surface charge distribution and volume charge distribution. I hope this is clear to you that this is a roadmap that what we are going to study under this video. So let's start with the first term, that is frictional electricity. Okay, so frictional electricity. So the definition of frictional electricity is the electricity produced by rubbing two bodies and transfer of electron from one body to another body. I hope you have done this in your childhood. Then And that time we rub the comb with our hair, and then it got some properties. The comb got some properties that it can attract the small pieces of papers. And other activities you have also seen that when we take comb near to our hairs, then our hairs get straight. Not like this, but somewhat like this. Okay. So these two are the result of frictional electricity. Okay. To understand the frictional electricity in a very simple manner, let's take a simulation. Okay. In this simulation, we are having, a balloon and a jacket. Initially, the jacket has positive and negative charge, or we can say the jacket is, or this sweater is electrically neutral because it has same number of positive charge and same number of negative charge. Or you can say it has same number of proton, it has same number of proton and same number of electron. Blue one are the electrons and the red one are protons. Okay. So what we are doing, we rub this balloon against this jacket. Then see what will happen. Okay. See what is happening there. By rubbing balloon onto the jacket or the sweater, the balloon has taken all the electrons or most electrons of the jacket on its surface. Since the balloon has its own electrons and it got some additional electron, that's why the balloon is said to be charged negatively. It is to be said that the balloon has been charged negatively. Okay. The electron of the jacket has been lost, so the protons of the jackets are dominating, so the jacket is said to be charged positively. Okay. And how we have done this? We have just rubbed the jacket. So by the friction, we have electrified these two bodies. This phenomena is known as frictional electricity. I hope this is clear to you that what is frictional electricity is. Okay? Okay. Now move to another example which will help us to understand the frictional electricity. Okay? So now we have a glass rod and we have a silk cloth. We are just rubbing these two materials. Then what we will see that the electron of glass has been transferred onto the surface of silk. Okay. So the glass rod is said to be charged positively because it has got a positive charge, and the silk is said to be negatively charged because the electron is received by the silk cloth. Okay. So why this is happen? You can read this. Electron in glass are loosely bound. That is an electron in silk. So that's why when we rub these two materials, the electrons of the glass rod is taken by the silk cloth. So that's why the silk cloth become negatively charged and glass rod become positively charged. Let's take another example. This time we are taking an ebonite rod and we are taking a flannel. Flannel means fur. When we rub these two materials, now this time this ebonite rod become negatively charged and this flannel become positively charged. Just opposite to this. In this silk become negatively charged and in this flannel become positively charged. Why? Because this time the ebonite rod take out or takes the outermost electron of this fur or flannel. As a result of it, the flannel become positively charged and ebonite become negatively charged. I hope with these three examples, the frictional electricity would be very clear to you. Okay, so we have to remember some of the following points related to charge, that electrification of the body is due to transfer of charge. A body is said to be electrified only and only when the charge either received or given by the body. Otherwise, the body is said to be electrically neutral. Okay. Second thing, if electron is ejected by any body, then the body is said to be acquired positive charge. And if any body get electrons, then that body is said to be negatively charged. Clear? So there are some examples uh, by which you can see that what will happen when we do different types of materials. For example, when we rub glass rod with silk, then the glass will become positively charged and the silk will become negatively charged, because simple obvious reason that the silk has more electroaffinity than glass, so the uh, outermost electron of glass is easily taken by the silk. Wool or flannel, when rubbed against amber, ebonite, rubber, plastic, then the wool will become positively charged and these material will become negatively charged. Same thing happened with the ebonite and polythene and dry home with comb. When you rub dry home with the comb, then your dry hair electrons will be taken by the comb, so the comb become negatively charged and your hair become positively charged. So when you bring comb to your hair, then hair attracted toward comb. I hope these all things are very clear to you. Now let's discuss some important things, that is properties of charge. We have seen what is charge is. It is just losing or gaining of electrons, outermost electrons. Okay, so there are some properties which we have to remember, or which is very important for the exam point of view. First thing is, there are only two types of charge: positive charge and negative charge. Either body will be positively charged or negatively charged or neutral. Neutral is not a charge condition. Okay. Second property is, like charge repel and unlike charge attract each other. This is very basic properties, that same things repel each other and different things attract each other. So it is not hard to remember. Okay. The next third property says charge is a scalar quantity. So It is also a very basic one, that if a body get charge, any body get charge, then that charge do not require any direction for their representation. You cannot say that this body have positive charge in this direction, this body have positive charge in this direction, this body have positive charge in this direction. You do not need to give the direction to the charge. What you have to do, you just have to tell what is the amount of charge. It has 2 coulomb, 3 coulomb, whatever charge it has. You just have to mention that. Okay, so charge, no doubt charge is a scalar quantity, not a vector quantity. Okay, now charge is additive in nature. For example, take an example that suppose we have a body, irregular bodies, and the body at this part, body have 2 coulomb charge. At this region, the body have 5 coulomb charge, and at this region, the body have negative 3 coulomb charge. Okay, so the net charge on the body, net charge on the body will be the algebraic sum of all the charges present over the different region of the body. Okay, so the net charge will be 2 plus 5 7, 7 minus 3 4. So the net charge would be 4 coulomb. This is called additive nature. The charge present on any body is also always additive in nature. Okay, and the next property is called charge is quantized. Okay, so what do you mean by quantized? Quantized means in bundles. In bundles. Okay, so this property means that if a body contains charge, then that charge will always be the integer multiple of elementary charge E. Okay, so this is elementary charge. Elementary charge means elementary charge value is 1.6 into 10 to the power minus 19 coulomb. If anyone asks you what is the charge of electron, then it will become negative. And if anyone asks what is the charge of proton, so your answer will be positive 1.6 into 10 to the power minus 19 coulomb. So the magnitude value, that is 1.6 into 10 to the power minus 19 coulomb, is called elementary charge, the basic charge. Okay, so this is elementary charge. So the charge on any body is the integer multiple of elementary charge. This is called the quantization property, that charge on every body is quantized. Whenever any body got charge, then it will always be in the integer multiple of electron. It simply means that you cannot have charge in the fraction of elementary charge. Okay, it is obvious that you cannot take half electron from anybody. Can you? So you can take 1 electron, 2 electron, 3 electron, or you can give 1 electron, 2 electron, 3 electron, thousand, billions, trillions. Okay, so that's why then when anybody gets charged, it is always the integer multiple of elementary charge. Okay, there is one more property, that is charge conservation. Charge conservation means charge in a system is always conserved. Okay, in a system means when one body gives charge. Suppose we have a body and we have another body. Okay, this body gives plus q charge, or this body has given q charge to this body. Okay, so this charge will not be waste. This body will get a deficiency. This body will get a positive charge, that is plus q, and that body will give negative q charge. But the algebraic sum of these two charge will result to 0. So initially the charge in a system was 0, and after transferring of charge, the charge in the system, the charge in this whole system is became 0. So this is called charge in the system is always conserved. You cannot eliminate any charge. You just transfer charge from one body to another. I hope this is clear to you. It is very important property of charge. Okay, the charge will not be eliminated. Only its energy can be taken. You cannot destroy a single coulomb charge. What you can destroy is its kinetic energy. You can just transfer the energy from one to another. Okay. One more property is that the charge do not depends on velocity. Whatever is the velocity of the body, the charge will not change with the velocity. Like we have seen in different fields, that the time also depend on velocity. If you are going with the velocity of light, then time will be only slow for you. Okay, so unlike that, the charge magnitude do not changes with velocity. I hope these all properties are very clear to you. So let's move to our next slide. So there's one thing you have to remember, that although we say that the fraction of charge cannot be possible, means you cannot have the fraction of electrons, but in our recent studies it has been seen that the charge can be in discrete format. This is the latest physics, modern physics. But we don't have to care about this, because we don't have to do it with the quark. So we will assume that the charge on a body is quantized. It means that it cannot have the fractional charge of elementary charge. Okay, so for our knowledge, we have to study that the quark of charge means fraction of charge, or it is the subatomic particles. The quark have a charge of 1 by 3 charge of elementary, and 2 by 3 E. It means 1/3 of elementary charge and 2/3 of elementary charge. These are called quarks. Okay. For example, we have a proton. Proton is made up of three types of quark. That is up quark. Up quark have a charge of 2 by 3 E, and a down quark. Down quark have a charge negative 1 by 3 of elementary charge. So when we talk about proton, the proton is basically made up of three quarks. that is upward, and downward. In a similar manner, so we have seen the properties of charge. I think this video will be very long if I try to teach you Coulomb's law in this video. So I will give you a second video in which we will study Coulomb's law in both vector and scalar form with some simulation and experiments. Thank you.